Section 3.5 is really a review of how to take the first derivative. It's called higher order derivatives because we are going to be finding the second and third derivatives. Sounds complicated, looks complicated, but it's really quite easy if you know your original rules of how to find the first derivative. And so first of all, let's look at some of the notation you might encounter. We've seen the first derivative and we've used the prime symbol. So sometimes we can use y prime. We've seen this differential. Haven't seen this too much, I think. So that is just the first derivative. And so now we have the second derivative. So we're using two little prime marks, either on the f or the y. And now we have the second differential. This last notation is not the most popular, and so forth. So we can use 3 prime marks, 4 prime marks, but past that we just put the number in. You will not be asked to find anything past the third derivative, I believe. The second derivative is just the derivative of the first derivative. The third derivative is the derivative of the second derivative, and so on. So in order to find the third derivative, you had to have found the second derivative, which means you had to have found the first derivative. So these are some problems out of your book in this section. So problem 4 asked us to find the first and second derivative. So I'm going to use that prime notation, and notice this is just a polynomial, so we can just use the power rule repeatedly. So I'm going to take my power, bring it down in front, multiply those together. Then the same thing. And then of course the derivative of a constant is 0. So that's the first derivative. So now I'm asked to take the second derivative, so I use 2 little prime marks. And now I'm just going to look at this and look at it like a brand new problem. Don't do anything different, just take the derivative. So again, I'm going to use my power rule, comes down in front, and that's my second derivative. So notice this polynomial was of the third degree, all right, because I had an x cubed. Then I took the derivative and I got a second degree down to x squared. Then I did the next derivative and I'm down to the first degree of just x. And so if I took the next derivative, I would just be down to a constant. Number 8 is a little bit more complicated because we're going to have to use the product rule. So in order to find the first derivative, we're going to use the product rule. So I'm going to identify the product there, and I'm going to use my u and v, then take the derivative. Don't forget to take the derivative of the inside part, and then I would multiply that 4 times 3 together. Alright, so the product rule says to multiply those together and then add it to the multiplying those two together. Let's see, I think this is supposed to be 3t plus 1 here. So I have 2t times 3t plus 1 to the 4th power. Alright, now that's my first derivative. I could clean that up a little bit. It might be easier, but now how could I do that? I could take out a greatest common factor and go from there, or I could just leave it as is. Let's see what happens if I leave it as is. And now that's the first derivative. I'm now asked to find the second derivative. Well, I want you to notice that I have a product here and a product here, so I'm going to have to use the product rule twice. All right, so this first one, I guess I will continue my u and v. Again, don't forget to take the derivative of the inside part. All right, so that's kind of enough for the first half, but what about here? Well, since I've already used u and v, let's choose 2 other letters. Doesn't really matter. I'm going to try a and b. This should look familiar. We've already done this part one time. Alright, so for the second half, again, I'm going to have to multiply those together and add it to those together. Same thing that way. Alright, so let's see. My second derivative. First half, 12 times 9 is 108. Okay, so that takes care of this part. Now I'm on the second part, so I'm going to add because I have adding. Alright, so 2 times 12, that's going to be 24t. Now that's my second derivative. It's not wrong, but it's certainly long. So let's see if we can clean this up. That's something we really need to practice. I want you to look for a greatest common factor. Well, hopefully you can see that they all have a 3t plus 1 to the second power. You're always looking for the lowest because that's what they have in common. So we've got a 3t plus 1 squared. They don't all have a t, but I believe they're all divisible by 2. So let's see what happens if I take out that GCF. Alright, 2 goes into 108 54 times. That's going to leave t squared, but this first one, all of that's taken out. Plus 2 goes into 24, that's 12t, and that would leave me one of those. Or the next one, that would be plus 12t times one of those. And then on the second one, the 2 is gone, and I would have 2 of those left. Now, is that any better? I don't know. Maybe. Let's just do some more algebra. We're finished with the calculus. And I hate using t's because they look like my plus sign, so I apologize. Alright, so I've multiplied that out. I've multiplied this out. Now I'm going to multiply that out. Remember, that's a trinomial. And you're going, why would I want to do this? To get better at your algebra. So let's see, 54 plus 36 plus 36 plus 9. That's 135t squared. Alright, then we have 12t, 12t, and 6t. That's plus 30t plus 1. So that is an alternative answer to the second derivative. Okay, some mathematicians would argue that that looks a whole bunch better than that long thing. But either one is correct. So let's look at this one. Again, we're asked to find the first and second derivatives. So the first derivative, just that power rule. So if I subtract 1 from 5/2, I would get 3/2. But then I have to remember to take the inside of the original function. So that's my first derivative. But I want you to notice I really don't like that fraction in front, and those both happen to be divisible by 2. So you could retake this 2 and reduce inside here, and you would be left with 5, and I'm going to bring this in front, w plus 1. That might be let me come over here. We have 5/2 times 2w plus 2. So what's happening is I'm factoring out the 2 there, and those cancel, and that's how I'm left with this 5 times w plus 1. Okay, so that's the first derivative. So now I'm asked to find the second derivative. Well, once again, I have a product. Now you can take this 5, you can leave it out to the side, doesn't really matter, or just take it with either u or v. All right, so let's see. I'm going to identify u to be that. And v to be that. So the derivative here would be 5 times the derivative of w plus 1 is just 1, so that's 5. All right. Now here's a little more complicated. Subtracting 1, I'm going to get a half, and I'm going to get that 2w plus 2 again, and I'm going to do that same thing with that 2 to make it a little bit prettier. So I'm going to have 3 times that w plus 1 plus that. Okay, so now I'm ready to take the derivative and find the second derivative. Okay, so I need to take that product. Now notice how they both have a w plus 1. So an easier way to write that, of course, is w plus 1 squared, and then added to that product. And that's certainly one way to write your answer. I would count that correct. But if we're talking about that GCF, well, let's see. They both seem to be divisible by 5, and they both have a half of those in common. So I'm going to take out a 5. I'm going to take this out to the 1/2 power. What would be left is, of course, w plus 1 squared, times 3, because I need a 15, plus the 5 would go, but now, if I took out a half and I have a 3/2, you would subtract the exponents, 3 halves minus 1 half is 2 halves, which is 1. And so that's how many of these you would have left, really to the first power. Now just to check, remember, if you multiplied this times this, you would keep the base and add the exponents, and a half plus 1 would give you the 3 halves. So I'm just going to clean this up a bit. Now remember, we could have stopped it here, but let's see what advantage we gained. So that's to the half power. I'm not too sure. Let's see. 3. FOIL that out. We can take that out of the parentheses. And then I'm going to kind of do 2 steps in one. I'm going to distribute the 3 and collect like terms. So that's going to be 3w squared plus 1w squared is 4w squared. That's going to be 6w plus 2w is 8w. That's going to be 3 plus 4 is 7. Right? So this would be another way to write the answer. This would be okay. That would also be okay. So now we have a quotient rule that we're asked to find the first and second derivative. Right? So we're going to go back to our quotient rule, that bottom and top stuff. Okay, so my first derivative, remember it's bottom times the derivative of the top minus the top times the derivative of the bottom, which is just 1, so you could just write t squared, all over the bottom squared. Now this is where, if you're going to need to find another derivative, you've really got to clean that mess up. So let's look at the top. Let's go ahead and distribute that and collect like terms. We could stop there, but let's see. If I factor out a t, is that going to help me? I don't think so. So I'm going to leave my answer like that. So that's the first derivative. It's also a quotient, so I need to do the quotient rule again. So you can use different letters, but I'm going to go ahead and use bottom and top, hopefully knowing that you're going to be talking about this last function. So the bottom, the top, and remember the derivative of that is just going to be 1. Okay, so here we go, the quotient rule again. So we're at the second derivative. The bottom times the derivative of the top. Let's look at this right here. Would that be 2 times t minus 1? Why might that be beneficial? Well, I already have a t minus 1, so I can write that as 2 times t minus 1 cubed minus that multiplied together. Is that same trick going to work here? I don't think so. So let's see. We've got t squared minus 2t times that. I'm going to stick that 2 in front, times t minus 1, all over the bottom, which is already squared, but we've got to square it again. Again, that is an acceptable answer, but I think we should really be able to reduce it because I see all these t minus 1s. All right? I see a t minus 1 here, here, and here. Remember, that's really to the 4th power. So since the lowest power is a 1, I'm going to reduce all of those by a t minus 1. So that's going to leave me 2 left here. That second one, that right here, is going to go away. And then since this was to the 4th power, that would leave me to the 3rd power. So I think that would be okay. You might want to distribute the top part out and collect like terms, but again, that would be okay as well. I'm going to go ahead and multiply all that out and see what happens. Don't lose that minus sign there. Well, some interesting things happen. Let's see. I've got those add out to 0, those add out to 0, and all I am left with is 2 over t minus 1 cubed, and that is my second derivative. Wow, that's a big difference. Okay, so now I'm finally asked to find the third derivative. You will notice it's just a polynomial. It's not that bad. All right, so we're going to find the first derivative by using the power rule. Okay, notice we've decreased it in power. Now the derivative of that, let's see, 4 times 15 is 60. We decreased in power one more time. And then the third derivative, you could have asked to find the 4th and 5th. We could stop, but let's just see. So the 4th derivative, and then the fifth derivative, and the sixth derivative is 0, and after that it's going to always be 0. Now again, we were just asked to find the third derivative, so we were to stop here, but I wanted to show you eventually on a polynomial, you just keep taking the derivative, it's eventually going to go to 0. So now we're asked to find the third derivative, and you're going, oh no, quotient rule. Rewrite this with a negative exponent. The top part's just a constant. Not really good to use a quotient rule there. All right, so our first derivative. Now remember, when you subtract one from a negative, you're going to get negative 6. That's going to be positive. That's going to be negative. All right, so look at here. When you have a negative exponent, when you take the derivative, notice how it keeps changing signs. Go from negative, positive, negative, and you would continue that pattern. So unless I've multiplied incorrectly, I believe that is the correct answer. Here you have a hint. The car begins to decelerate when acceleration is 0. All right, and just to tell you, acceleration, right, so you have distance, you have velocity, and you have acceleration. If distance is the function, the velocity is the first derivative, and acceleration is the second derivative. So you might want to, acceleration might have something to do with that.